So today we are going to talk about using the Pythagorean theorem. So today our I can statement is going to be I can use the Pythagorean theorem. Okay, so we're going to talk about triangles a little bit. We'll talk about parts of triangles first, and then we'll talk about what the Pythagorean theorem actually is. So sides of a right triangle. The sides of a right triangle, sides of a right triangle have special names. So these parts are called legs. You guys have it right there. The legs are the two sides that form a right angle, so we could label this as leg A, and this could be labeled as leg B. So we'll just label that as A and B. This part, this green line is different. This is the hypotenuse. Why is it called that? I don't know. It just is. It's just a label we give, and we will label this as part leg C, or side C. So we have side A right here, side B, and we have side C. So what this is saying is how can we use this to help us find the different sides of a triangle? In any right triangle, the sum of the squares of the lengths of the lengths of the legs is equal to the square of the length of the hypotenuse. Okay, so that probably has absolutely no meaning to you right now, so that's what I will do. I will explain what that means. Here's the formula that you will have to memorize, that you've probably already seen before in other places, but now we're actually going to learn it and apply it as well. It is a squared plus b squared equals c squared. Okay, so pretty much what that is as we said, we have, going back to original triangle, we have leg A, leg B, and we have hypotenuse C. So if I square my legs, so if I square leg A and if I square leg B, that is, and I add those two up, that is going to be equal the square of the hypotenuse C, and this will always work for right triangles. So for example, if I were to take a look here, my hypotenuse is always going to be opposite of my right angle. So in this case, here's my right angle. This is going to be my hypotenuse. Okay, it is always going to be the longest side of a right triangle. It will never be touching the right angle as well. So we could label this as A, B. It doesn't matter how you label it as. You can label this as A, B. It really doesn't matter. And this as C. Likewise, this could be A, this could be B. Those two don't matter, but C must always be the hypotenuse. So you could even write C equals hypotenuse always, and then A and B are equal to your legs. Okay, so let's take a look here. There's just 4 steps on how to solve this. So example 1, finding the length of the hypotenuse. So as you can tell, I'm trying to figure out how long this letter C is, this side of the triangle. Step 1 is write the formula for Pythag. I just didn't want to write Pythagorean theorem out every single time, so I just labeled it as Pythag or Pythag, or you guys will hear it in different ways. In your high school teachers as well, they'll probably say it differently too. So I always write it down: a squared plus b squared is equal to c squared. Okay, step number 2 is label your legs and hypotenuse of the triangle using a, b, and c. So this is nice. C is already labeled for us. This could be A, this could be B, it doesn't matter. So you could have 15 be B, you could have 15 be A. Order doesn't matter because of the commutative property of addition. So now that's all step 2 is. So, and I just write that as C. Step 3 is substitute in the values. So A is 15, right? So I'm going to take this formula and I'm going to, instead of A, I'm going to write 15. I always put it in parentheses no matter what. B, according to my triangle, is 8. And that is equal to c squared. Okay? So from here, well, now let's simplify and solve. So 15 squared, perfect square is 225. 8 squared is 64, is equal to c squared. If I add 225 plus 64, you get 289 is equal to c squared. But you're like, okay, so now how do I solve for this? So once you get to this point, once you have your exponent, you have a square on one side and you have only an integer on the other side, then you take the inverse, right? So we always do inverse operations, right? If I have subtraction, the inverse would be addition. If I have addition, inverse would be subtraction. Multiplication, division. Division is multiplication, right? So the inverse of a square is equal to square root. Okay, so what do you think the inverse of a square root is going to be? It is going to be you square it. So in this case, I have a square, so I have to take the inverse of that, right? So I need to take a square root of both sides. So square root of 289, that is a perfect square, that you get 17 is equal to just c. When I take the square root of a square, these cancel out and I'm just left with just the inside variable all by itself. So I'm left with the hypotenuse is 17 feet. Don't forget your units. Okay, so if you were confused, if you want to rewatch this part, you could rewatch it now. If not, work on your own using the example we just did. Okay. Example number 2, finding the length of the leg. So sometimes we would have to solve for different parts of the triangle. So in our previous example, I was solving for hypotenuse, right? But now I'm solving for a leg. Same exact thing. So write down, step 1 is write down the formula. Okay, now let's label my points. Well, if this is A, then this must be, or excuse me, that's B, this must be A, and this is C, right? Whatever is opposite of my right angle is always going to be my hypotenuse. So now I label that. So step number 2. Step number 3, let's plug it in. So a squared plus b squared equals c squared. A squared is, let's see, 3.5 squared plus b squared equals 6.5 squared. All right, so now let's simplify. So remember, calculator, please use it, especially when you're squaring decimals and all of this stuff. So you get 12.25 plus b squared is equal to 42.25. Okay, so like how we would always solve for variables, we want the variable by itself. So I have to get rid of this. How? By subtracting it to the other side. So now I have b squared is equal to 30. Okay, so from here, as we said earlier, you do the inverse operation. The inverse operation of a square is a square root. So I'm going to take the square root of both sides. Okay, so now I have b is equal to the square root of 30. Now let's see if we can simplify this, right? So remember, use the tricks that we talked about earlier. Can we simplify this further? Is there a perfect square that fits inside 30? So I cut it in half, you get 15. That my perfect square is 1, 4, 9, 16, 25. So that would fall right here. So 9 does not go inside 30 evenly. 4 does not either. So that means this is my most simplified form of the square root. Okay, so it's exactly the same way as how you would solve any other equation. So why don't you guys try on your own? If you're confused, as I said earlier, you could go back and rewatch it, and hopefully it'll help you out. Okay, so for this word problem, it says a zip line starts on a platform that is 4 meters above the ground. So if I were to draw it, let's say that's about 4 meters above the ground, and let's say all of this, that's a terrible ground, but that's the ground. The anchor for the zip line is 8 horizontal meters from the base of the platform. So 8 horizontal meters from the base of the platform. Find the length of the zip line. So here's where the platform is. So here is my triangle. there is my right angle. So for these word problems, you will always be given a right triangle, so you have to practice drawing them out right from what the word problems are saying. So you have to interpret them and then be able to draw a picture, and from here you can figure out the length of your zip line. So always write out your formula. Okay, remember the side opposite your right angle is always going to be your hypotenuse. So that means this is my A, B, so I have 4 squared plus 8 squared equals C squared. Okay, so if I square it, I get 16 plus 64 equals C squared. I'll finish that over here. So if 80 is equal to C squared, so as you said earlier, your inverse operation is square root. So now C is equal to square root of 80. So now the question is, can this be simplified? The answer is yes, it can, right? So remember your perfect square sheet. I forgot what's next. 749. We'll stop there. Okay, so half of 80 is 40, right? So 40 would fall here. 36 going to 80. Nope. 25. Nope. 16. Yes. Right, so this can be split up into square root of 16, square root of 5. No. Yes, square root of 5. And square root of 16 is 4. So this is the answer is 4 root 5 meters is going to be the length of my zip line. Okay, so that's why we had to learn how to simplify square roots before we do Pythagorean theorem, because a lot of this stuff does include it as well. The next word problem I wanted to talk about is we'll also be dealing with squares. So the perimeter of a square is 81 centimeters. Find the length of the diagonal of the square. So if the perimeter is 81, the area of a square is 81 centimeters. So the area of a square is 81 centimeters. A equals 81. What does each side length represent? Well, area is side times side, right? So what two numbers, when I multiply them, will give me 81? I know that my square is going to have 9 and 9 for my area, right, for my side. So from here it says find the length of the diagonal of the square. The diagonal of a square is from corner to corner. So, well, how would I figure that out? It's not going to be 9. The diagonal is longer than 9. So remember, this is a right triangle. So if I were to take this triangle right here, redraw it, 9 and 9, can I figure out this diagonal? Yeah, you can, right? Remember, opposite is going to be your hypotenuse. So you have a squared plus b squared equals c squared, right? So you have 9 squared, this is your a, this is your b, plus 9 squared equals c squared. 81 plus 81 equals c squared. 162 is equal to c squared. Okay, so you have to take the square root of both sides, right? So from here, we're like 162. How do I do that? Well, do the perfect square. Cut it in half. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. So half of 162 is 81. Boom. Let's start with 81. Yeah, 81 times 2 is 162. So we got it on our first try. So this can be split up into square root of 81, square root of 2. Square root of 81 is 9 root 2. So the diagonal of this square is going to be 9 root 2 centimeters long. Okay, so I know I definitely didn't give enough room for the word problems here, but once again, try this on your own for this lesson. Draw a picture, it'll help you out. And then once you do that, fill out your level of understanding. Feel free to rewatch any portion of this video if you are still confused. See you guys.